Hi, Mr. Wagner here. We are going to learn about Arduino making music today. Okay. Um, let's see here. Let's go first here. We are on robotics. Okay. Robotics. And if I go to topics, here's fun with Arduinos. Remember, this is where all our stuff is. And I'm going to click on it. Arduino Sound, make some music. This is the slideshow that I'm going to show you. Once I get this video done, it'll go right here. And then here's some Arduino code, okay? Now, I think you guys are going to like this one, this particular lesson, because it makes some noise. Okay, so here's my slideshow. Let's go ahead and make this full size. And okay, so the first thing, actually, I'm not going to make it full size. So the first thing I'm going to do here, we are going to be using our Arduino and we are going to be connecting it to what's known as a piezo buzzer. And piezo is spelled P-I-E-Z-O, buzzer. And the little buzzer, if you put some electricity on it, it makes this little thing vibrate back and forth, okay? So let me show you what it looks like on the camera. Let me show you what the circuit looks like. Okay, so this thing, this little guy here is called a piezo buzzer. And you're going to find it in this little box here. A lot of times it'll have that little sticker on it, so you won't peel that little sticker off, okay? But anyway, this is the little piezo buzzer. And a couple things you want to look for. One is, notice how there's a plus on that? That plus corresponds to the pin that's on the back here. They call these pins, okay? So that little pin is the plus side of the pin. That is what's going to go to your Arduino pin 8. The one that's not plus will go to ground. Remember, we decided ground was 0 volts. Okay, now I'm going to plug this in, but I want you to notice if I try to plug it in across two things, it's like there's almost, well, there we go. It's like there's almost not quite enough room. So what I'm going to do is I'm just going to plug it in one further away. Now notice how, see, I'm going to put it here. It looks like I have the negative pin plugged into row 25, and I have the positive pin plugged into row 23. So if your sound doesn't work, you do have to pay attention to what you plugged into where. Okay, so I'm going to shove that in there, and it's going to fit flat. Okay, flat, just like that. And I said the ground is on row 25. So I'm going to plug the ground into 25, right? And I'm going to plug this side into ground over here, okay? And then the other one goes into pin 23. So not 24, but 23 goes in there. And what we're going to work with on this one is pin 8. Okay, so pin 8 is all the code. So this one's actually really easy to hook up. So pin 8 goes to the plus of the piezo buzzer, and the ground goes to ground. Any questions there? That should be fairly straightforward. If not, if you look at this thing here, this is actually a piezo buzzer. Red means plus. Red means plus. And it goes to pin 8. You can make this a little bit bigger. And then the ground goes to ground. This is a schematic view of it. I put it on there just so you sort of get used to how that looks. But that's it. Okay. Now, the code that we're going to mess with looks like this. I want you to look here. Notice how on Arduino, I'm just using it in the setup part and the loop part. I actually already have the code here. Okay. And let's just talk about this. So in setup, this bit just runs once. Okay. There's one command. The command is basically tone, and it uses three parameters. Parameters are the thingies that are within the parentheses. So the three things in the parentheses are pin, frequency, and duration. So the pin is the Arduino pin. The frequency is basically the tone, the note that we're going to be making. And the duration is how many milliseconds, okay? So in the case of this, we have our tone, and then our frequency. Our pin is pin 8 because we plugged into pin 8, remember? The frequency is 440 hertz, and the duration is 1 second. And then I'm going to delay for 2 seconds, okay? Because this tone thing, it does not, it like starts the tone and then the tone doesn't go away until it stops, okay? You can also do it this way where you don't have the duration in and you use the delay for duration. Okay, now I'm going to upload it. And you notice how it made two noises. Did you hear that? I know it was really quiet, but actually if I hit the reset button here, let me go back here. If I hit this little reset button, then it'll play the code again. So there's one note, there's another. Okay? One note and another. Okay? So I'm going to go back to my slideshow and let's just talk about this just a little bit. All right, y'all paying attention? Hope you're paying attention. Okay, so sound. Have you all, just raise your hand if you've messed with sound in like physics class? Have you messed with sound at all? What? You did not take physics. Okay, so basically sound, like if you have a speaker moves back and forth, okay? Moves back and forth. And when it moves back and forth, it pushes air molecules. And then those air molecules get pushed all the way to your ear. And then your brain interprets that as sound, okay? Does that make sense? Okay. So that's all we're basically doing here is we are sending a signal to the piezo buzzer, which is then pushing air to your ears to make noise, okay? Now, it happens to be the sound, that the electrical signal that we send to the piezo buzzer is basically just an electrical signal where the voltage goes 5 volts, 0 volts, 5 volts, 0 volts, 5 volts, 0 volts. And if it sends that to the piezo buzzer fast enough, then it makes the sound, okay? Okay. Now, what it does is it basically sends what's known as a square wave. So if this red on here, this is my electrical signal. So I'm going 5 volts and then down to 0 volts, and then 5 volts and then 0 volts, and 5 volts and 0 volts, okay? So basically that pin 8 is just going 5 volts, 0 volts, 5 volts, 0 volts really fast, okay? Which then vibrates that little thing inside the piezo buzzer, which then moves the air molecules, and then those air molecules go into your ear to make noise. Okay, a lot going on there, but that's how it works. Now, frequency, okay? Look up here. So if remember how I said it goes from 5 volts to 0 volts to 5 volts to 0 volts, each one of the times it goes from 5 volts to 0 volts, that is one cycle. Okay, that is called one cycle. And frequency is basically how many times it goes up and down in voltage per second. Okay, and frequency is measured in hertz. Okay, hertz. It's probably named after some old dude. And middle C on a piano, when you hit that, basically the sound wave goes up and down 262 times per second to hit that middle C. Okay, kind of with me there? I know I'm throwing a lot at you, but that's how that works. Okay, so our code, the main bit of code that we write here is called tone, because we're creating a tone. We look at the pin, the frequency, and the duration. Okay, so the pin is Arduino pin 8. The frequency is whatever frequency we want that tone. If we want a high frequency, that tone's going to be a number that's a high number, say like 1,000 or 2,000, right? And if we want a low frequency, that would be like 100 or 200. Now, your hearing range is usually from about 100 hertz all the way up to like 40 or up to like 20,000 hertz, 22,000 hertz. As you get older, your frequency will drop off. Or if you have like your ear is not working as well, like you've been to like too many rock and roll concerts, right? So you'll notice older people can't hear real high frequencies, okay? And dogs, they can hear really, really high frequencies. Have you ever heard of that? Okay, it's all the same stuff, okay? So basically, that's the frequency. Duration is how long you want to play that note, okay? There is a bit of code called no tone, and you pass it the pin, and that'll basically just turn off the tone that's being played, okay? So if you turn on the tone and then you turn it off, then it'll stop playing. Another little bit of code, I don't know, have you ever, I know Mac has done computer programming. Have you ever messed with constants in programming yet? Not loops, but a constant. So a constant is like a variable, but it's a variable that never changes, okay? Okay, it's a variable that never changes. And in this code that you're gonna mess with today, we got constants. So basically, the code for a constant is define note B0, say 31. Now it says this line of code basically says there's a number, 31, and it is assigned to wherever note B0 is. So anywhere in your code where you see note B0, the computer just substitutes the number 31, and it's called a constant. It makes your code a little bit easier to read, okay? Now, your assignment, should you choose, no, there's no should you choose, that's from whatever, is we're gonna build this circuit, okay? And connect the positive to ground, or positive to B8, or to pin 8, and the negative to ground. And then we're going to copy and paste the code from Blackboard Topics to run in your Arduino. So I'm going to show you that real quick. So I'm going to go into Arduino and I'm going to do a file new. Okay, so there's my new code, nothing there. I'm going to go into here, see where it says save and a haircut, copy and paste. This is my code. It says copy and paste the code below. So start here, go all the way down, Control C to copy.
What's that code for?
I'm going to show you in just a second. And then I'm going to paste it right here. Okay. Now, what this code does, first off, all this stuff here at the top, these are all the different notes. So like the note middle C is right here. Note C3 is 131. No, wait, I think note C4 is middle C. Okay, so there's middle C, C4. C sharp 4 is the fourth octave. I don't know if you've ever had music class or whatever, but note C4 or C sharp 4 is C on the C sharp on the fourth octave. But basically this just defines each note as its frequency, okay? And these are frequencies that are the frequency in physics, okay? And basically this means that, you know, like if I want to do G7, 31, 36, then that means that 5 volt, 0 volts is going to go 5 volt, 0 volts, 3,100 times a second, okay? Now, if we scroll on down, I have a couple other defines. One is quarter duration. So that's quarter note duration. And then I have eighth note duration, okay? If you want to create a 16th note or whatever, you can do that. Just copy and paste the code, figure out what the numbers are. But then I have my notes. So line 104, I'm playing middle C for a quarter note, and then I'm delaying for a quarter note. And then I'm playing G for an eighth, and then G for an eighth, and then A for an eighth, or A for a quarter, and then G for a quarter. And then here I have a rest because that's 0. I'm not playing a note. And then I'm playing B for a quarter and then C for a quarter. And if I upload this, it plays that shave and a haircut. Did you hear that? Okay. So your assignment, let's see if I can find it again, your assignment is basically, I clicked the wrong thing. Sorry, hang on. Okay, so your assignment is basically this. Build the circuit, copy and paste the code, and then change the song to whatever you want, okay? It's okay if you play Shave and a Haircut first and then put your code behind that. But you could play Happy Birthday, you can Mary Had a Little Lamb, a Mario theme song, whatever you want, but at least 10 notes, okay? At least 10 notes. If you Google simple song, you'll find where somebody will say, okay, here's how to play Mary Had a Little Lamb, and it'll be like, you know, C, 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 D, D, C, D. Okay, okay, I don't know what the actual notes are. But basically, you're just sort of copying and pasting code like this. And then when you hit play, it'll download that code and then play, hopefully. Does that sound interesting to you? We're going to see how it goes. All right. Okay, that's what I have there. I will be coming around and helping you. I would suggest trying to just get the noise going first. Okay. And you can do that by just getting just copying and pasting the code. And then when you hit download, it should play. And then we'll go from there. All right. All right. On your mark, get set, go.